All right, welcome back to math class. We are now beginning lesson 22. Today should be Wednesday. I'm sure what the date for this is. Wednesday the 14th. So Wednesday, February 14th. And yesterday we should have finished out lesson 21. Lesson 21, that would have been the end. And we were relating decimals and fractions. Today we are going to continue comparing decimals, and you can see there's some fractions. If you're on page 229, you should be in your book on page 229. I'm going to pull out a piece of paper here to write on. But if we look up at the example problem, they have this kind of done for us already. And they're using models. You might have seen these last week as we did some of these. I asked you guys to do some of this for homework. And so it's wanting us to put 9/10 in the form of a model. And you can see that it has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 rectangular boxes here. They're like long rectangular boxes. And it's all inside this larger box. And out of this whole single box, this one box, 9 out of the 10 sections are colored purple. So that means 9/10 of this box is shaded in. And it wants us to compare 9/10 to 5/10. So if it just said compare 9/10 to 5/10, this is one way, just one way that you might visualize it. So here's the same box, same one total box. There's one box here, one box here. This one has 9 of the 10 boxes shaded in, or 9 of the 10 like long rectangular areas shaded in. This one only has 5 of those shaded in. And as you can see, there's less shaded on this one than there is on this one. So if we're to compare 9/10 to 5/10, it's pretty easy to then look and say that, okay, 9/10 is greater. When you see these little carrots like this means greater than. 9/10 is greater than 5/10. So very good, very easy. Well, there's other ways that you can write this, and they show us another way down here. Use a number line and the fraction 1/2 as a benchmark. So if we're to write this whole thing equals 1. This whole thing from 0 to 1, it equals 1. So and it's cut up into 10 divisions or 10 different places. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it has 10 different areas along this line that it's divided into. If we were to kind of go this out, it would look exactly like one of these. You can make it into a big box. It has 10 different sections of it. But it's maybe a little bit easier on your paper if you're writing to write out something like that. You can write a line and cut it into 10 different divisions a lot easier than you could. So I'm going to do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I can write that out on my paper a lot easier than I could try to write one of these boxes out if you're having to do problems. So we're going to do the same thing down here that we did up here. We're going to compare 9/10 to 5/10. Well, 5/10 is equal to 1/2. We did that in yesterday's homework. If you're to compare those, it's not too difficult. The 5 is divisible by 5. It equals 1. And 10, 5, 10, if we're counting by 5s, it goes in there twice. So 5 goes into 5 one time, 5 goes into 10 two times, it's 1/2. So, you can easily say 5/10 is equal to 1/2 without giving it too much mental effort and wearing yourself out. 5/10 equals 1/2. And so if we were to mark these out, we could say the 1/2 point, 5 out of 10. So 1, 2, 3, 4, 5 is 5 out of 10. And if we go all the way up here, 6, 7, 8, 9, 9 out of 10, you can see this is closer to 1. So this 1/2 is down here closer to 0. If we're to compare this 9/10 is obviously the bigger number. It's closer to 1 than this smaller number is. So 9/10 is greater than 5/10, or it's actually written the opposite way. 5/10 is less than 9/10. But yeah, so that's kind of an easy way to think of that. But so for this assignment, for today's work, we are going to be working with these number lines. So you guys will get used to looking at and comparing these. And this is not too difficult once you slow down and just take a look at it. So all you have to do is to be able to count the numbers all the way up to 10. So the directions, is always a good idea to read the directions. As you saw yesterday, I didn't read fully the directions and end up messing up one, which is what was kind of supposed to happen, I guess. But they asked us, and it was easy to identify then. So we found our mistake, and that worked out. But so for number 1, label 2/10 and 6/10 on the number line below. Write a symbol to compare the two fractions. So I'm going to use my thing up here that I already drew out instead of writing in somebody else's book. And I'm going to write down 2/10 and 6/10. So if I go along my line here, you already know that I wrote out 10. So if I count 1, 2, this one equals 2/10. I really could probably just circle it and remember that it's 2/10, but I'll go ahead and write it down anyways, just for the sake of clarity, make sure we don't forget, mess anything up. So we can see that's 2/10. Up here we have 1, and over here we have 0. So, 0 and 1. So between 0 and 1 we have 2/10 here. And we also need to label 6/10, and then we're comparing which is bigger. So 2/10, so 2, 3, 4, 5, 6. So I'm just counting. All you have to do is be able to count, and you can label these. I probably could have just circled it and remembered it and compared them that way, but these are also you can simplify these, but at least for this, we don't have to. Everything's at a 10. We have a 10 number line. We don't really need to do that. So 6/10 is obviously bigger than 2/10 because it's closer to 1. As far as things go, things going this direction over that way ends up getting bigger, and things that go this direction over here ends up being smaller. So 6/10 is greater, it's larger than 2/10. So if we're to compare them, we can write these out. 2/10, and it is less than 6/10. And there's a noise going on in my classroom. I'm not sure what that is. Hopefully that stops soon. But 2/10 is less than 6/10. 6/10 is the bigger number, as you can see right there. So that's an easy way to compare those using the number line, and you can write that. So remember these number signs. If it's this way, this is greater than. It's saying this first number over here, and I'll be back in 1 second. I want you to go ahead and look at number 2. Try to solve that and try to compare these looking at this and read through this. Try to do that, and I'll be back in just 1 second. All right, so hopefully you guys were able to solve that. As you can tell, I don't know if you can hear that noise, but it's very irritating. Hopefully it doesn't show up too much on the video, but I can't really help it. I don't know what's going on in my classroom. So that is the radiator that you guys sit by in the back there. Number 2 says, look at problem 1, which we kind of worked that out. Explain how to use the fraction 1/2 as a benchmark to compare 2/10 and 6/10. All right, so if we add that, we can just add that to our thing. We have 6/10 here. We know that 1/2 is equal to 5/10. We did that yesterday. We did it in our example problem up here. And, out of 10, we know this is out of 10. So the reason that we would use 5/10 as kind of a benchmark to compare is that it's already on our number line. We know that 5/10. So 5/10 would be kind of somewhere in the middle, closer to 6/10. We know that it's about halfway. So even if you didn't know it, if you just did it here, if you just kind of like compared this, you know that 5/10 is going to be somewhere about the middle. But if we were to compare that, we'd say 5/10 is somewhere kind of closer to the 6/10 side. And if we were to look at it along the way, if we were to cut this up, this line here, if we were to cut it up into tenths, we would put 5/10 directly in the middle. So not really a whole lot to do there. You could actually just make a mark here and say 5/10, make a mark here, say 6/10, and you'd probably go way down here and say 2/10. And you would mark that along because you want to show that 5/10 is pretty close to 6/10 and 2/10 is way further down because it's a much smaller number by comparison. All right, number 3, they want you to label 10/10. any number divided by itself is equal to 1. So if we're looking at this number line, we can see zeros way down here and ones up here. And 1 is equal to 1. So if 10 over 10 is equal to 1, I'm going to draw a line, kind of separate out my work so it's easier to follow along with. Write down number 3 here. And we say 10 over 10 is equal to 1. So that one's easy to identify. It's right there. It's 1. We've already labeled it. All right, and 8/10 on the number line below. Write a symbol to compare the two fractions. All right, so we say 0, 1, 2, 3, 4, 5, 6, 7, 8. So 8 is located right here. So that's 8/10, 8 out of 10. So 8 over 10 is less than 1, because 1's over here, and 8 over 10 is over here. So 8 over 10 is less than 1. So we're going to say that it is less than 1. We want the kind of Pac-Man guy, little alligator, I guess, or whatever. You could think of it like a Pac-Man if you want. He always wants to eat the bigger number. So we can make like a little Pac-Man guy. And he's like, and he's eating the 1. He's going towards the 1. So this number is, we always read from left to right. So we say 8/10. Is it bigger or smaller? It is smaller. So it is less than 1. So that's the way that we would write that. We would write 10/10, or I guess you could write it this way. If you make the bigger number on the left, 10 over 10 or 1, these are synonymous. We wrote up here that 1 equals the other. It's the same number. 10 over 10 is equal to 1. You write 10 over 10. If you write 10 over 10 here and 8 over 10 here, then you would have to write that 10 over 10 or 1 is greater than. It is greater than 8/10. So the Pac-Man's always eating, or the sign is always eating the bigger number, but you have to change it to reflect whichever side the bigger number is on. So up here in this first example, I'll call them A and B. And A, I wrote the one on the right-hand side over here, and in B, I wrote it on the left-hand side. So important information for you to know to doing these kinds of problems in the future. All right, I'm going to go ahead and turn the page. So the symbol, when you're comparing those, you probably should have circled the 1 here, and then the 8/10 section, because this is 8 over 10, or 8 out of 10 divisions is right here. And yeah, the little Pac-Man then would probably be eating the larger one, the 10 over 10 there. This is equal to 1. All right, and for number 4, you're back to some of these shading concepts. So we kind of moved away from this a little bit. Oh, bumped my camera. Moved away from it a little bit. Now they're returning, and we're going to look at it in different forms. All right, so number 4 asks us to shade and label the models below to show 3/10 and 3/100. Okay, so write a symbol to compare the fractions. So this is pretty, not as difficult as you might imagine. They want us to highlight or shade in 3 out of 10. So if you look at this is 10 divisions or 10 different sections of a square, and they just want us to highlight 3 out of those 10. So if you shade in the first 3, this one, and this one, all the way up and down, because it's out of 10, then you will have fulfilled the assignment. That will be 3 out of 10. 3 out of 10. And I'm going to write some boxes here to kind of reflect the same thing. And I'm going to put a 5 in the middle, and then 6, 7, 8, 9, 10, 4, 3, 2, 1, and I'm just going to loosely draw those in. It's not particularly artistic and beautiful, but I'm trying to do it real quick. I don't actually have a textbook of my own that's not already done. So if we want to do 3 out of these 10, so there's 10 squares here, I'm going to color in the 3 that I want done. Doesn't have to be super artistic, but that one has the 3. I'm not going to write in the 100 because that's too much work. But if we were to shade this in, this is 100 boxes. So it's 10 boxes this way and 10 more boxes this way. So now they've divided this up. These are both the same. These are the same size, but this one's divided up into 100 little tiny squares, and this is divided up into 10 of these big rectangles. So this is out of 100, and they want us to do 3 out of 100. Well, don't get intimidated by the number 100 there. It's not too bad because they still just want you to do 3 of those 100. So you just have to find 3 boxes. You could do 3 this way or 3 this way and highlight those boxes, and bada bing, bada boom, you got your 3 out of 100. So 3 out of 100, if I were to draw it the same kind of size, I'm not going to draw in all of those little circles again, but it should probably look kind of like this. Out of 100 squares that were, if I were to draw those all the way across here, all the way across and do the whole thing, only those 3 is what it asks us for. So it's asking us for 3 out of 100. All right, so that's pretty easy. Not too bad to compare. If we were to compare them, 3 out of 10, as you can see, is worth way more than 3 out of 100. So if we were to write 3 over 10, and 3 over 100, then our Pac-Man guy, if we were to do greater than or less than, 3 out of 10 is greater than. It is more. It is a bigger number than 3 out of 100. So our Pac-Man, if we were to draw a Pac-Man there, would be eating. He would be eating the 3 out of 10. Maybe I'll draw some jagged teeth on him because he's, okay? All right, I don't know what that was supposed to be, but 4. That was number 4. I'm going to write number 4 there. I'm about running out of room on my paper, so I'm gonna have to move on to another sheet of paper. This is just the front of this paper, but yesterday's homework I did on the back. So we're almost done, but let's see if we can fit 5 and 6 on the same page. So 5 over here, not a problem for you guys because you have your books. It says for us to use the symbols less than, greater than, and equal to compare the fractions. So this one is less than. It means the number over here is less than the number that's over here. That's why the Pac-Man is eating the one to the right. This one, so it's always, this symbol will always mean less than when it's eating the one to the right. When it's eating the one to the left, it means it's greater than. So it means if we're reading from left to right, which is how we read in English, it would be the first number is bigger than the second number. All right, and then equal to, of course, means they're the same. They equal the same amount. And to do this, we have to actually kind of write these out. So I'm going to write out A and do that one. So they want us to compare 5 over 10 to 50 over 100. Well, if you remember from yesterday's lesson, there's a way to compare the zeros. So both of these numbers end in 0. We can cross out our 0 here, cross out our 0. Is 5 over 10 equal to 5 over 10? Yes, it is. They are equal to one another. So number A, or letter A, is equal to. They equal the same amount. B wants us to compare 4 over 10 to 4 over 100. Well, these both have 4 on top, but as you can see from up here, remember that a number out of 10 compared to a number out of 100, there's a big difference. So just looking back at number 4, if we were to visualize this using these boxes, I could shade in 4 of these big boxes here, which you should have already shaded in the first 3 because this question actually asks us about this. But if I shaded in 4 and then I shaded in 4 of these little boxes here, there's not nearly as much. The 4 out of 10 is a much bigger number than 4 out of 100. So we can safely say that the Pac-Man is going to want to eat the 4 out of 10. 4 out of 10 is much bigger. All right. C wants us to compare 11 out of 10 to 12 out of 10. All right. What does that mean? Well, the denominator in this case is the same. These are both improper fractions because the number on the top is bigger than the number on the bottom. And we don't really have to convert anything because the denominator is the same. It makes it very easy to compare them. So the real question is just, is 11 bigger or smaller than 12? And the answer, of course, as you know, is that 12 is bigger. When the denominator is the same amongst the two numbers, then you don't really have to do too much to compare. You can just easily say 12 is bigger, it's greater than 11. Or the way we would word this, reading from left to right, 11 is less than 12. All right, so I'm going to go over to D and see what that says. 62 out of 100. 62 over 100 is greater than or equal than or less than 6 over 10. Oh, wait. Yeah, 6 over 10. Oh, it's 62. Yeah, 62 over 100 compared to 6 over 10. Well, these could be very close to each other. If this were a 0, if this said 60 over 10, then we could do our trick where we just cross out the zeros, and that would make it really easy. But unfortunately, sadly, we cannot do that. So 62 over 100, if we're to compare that, we could kind of use a decimal point. We kind of did something like this yesterday. I showed you that a number over 100 is very closely related to a decimal point. So I could say 6.2 is 6.2 over 10. And we can kind of get rid of this 0. So if I did that, 6.2 over 10. All right, so I just moved my decimal point. I moved my decimal point 1 here, so I have to move my decimal point 1 here. So instead of over 100, now it's over 10, is 6.2. And if I do that, it makes them the same denominator. So we have 10 over here and 10 over here then. I just move my decimal point. That's an easy way to do that. And then 6 over 10, that's a trick that you'll probably learn in your small group time. Again, I said we would be revisiting some of those decimal things, decimal comparisons and fractions. That may not be today, but you will be doing a lot more of that to learn how to do it. So 6.2 is greater than 6. So only by a very small point, by a decimal point. 6.2 is 2/10 of a 1. So 6.2 is just slightly, just very ever so slightly greater than 6/10. So in this case with D, you could say that this number, the 62 over 100, actually is bigger than 6 over 10. And then E, 9/10, I'm not going to write that out. That is very similar to some of the other. We can't really get rid of the 0 or convert these, is just are they are. So 9 out of 100 would be just the same as we see up here. If this were to shade in 9 things, it would cover almost one entire rectangle, but not fully, and it would go all the way up to there. And if we were to shade 9 out of the 10 here, it would cover almost the entire square. So, you know, compared to the two, 9 out of 10 is almost equal to 1. It's almost the whole square, whereas 9 out of 100 is not even an entire rectangle of our section here. So the 9/10 is much, much, much larger than 9/100. So, you know, if you're to make a little Pac-Man guy eating one of those, then you would say 9/10 is less than. So it would be eating the 1 this way. It would be eating the 9/10 because it's bigger. It would be less than 9/10. So you would have the Pac-Man. If I write that out, I'm just going to write 9 over 100. I'll write it down here. It's kind of sectioned off from these other guys. All right, E, and circle that. 9 over 10 is less than. Notice I wrote my little less than symbol there. Less than 9/10, because 9/10 is a bigger number. All right, and I don't know that I need another section for this last one, but it says write the fraction that each model shows. Explain which fraction is greater. Well, this is going to be out of 100, so I'm just going to make a section. I have a bigger area to write on up here. I'm going to make an area of here. Usually I wouldn't want you guys to do this, but I don't want to get on another sheet of paper, so I'm going to do it lazy. I'm going to be lazy today. And I have this whole section here to write with now, 6. So we have, everything's out of 100, because you can see there's 100 boxes. You don't have to count them. Just remember, you know that this box up here at 100, there's 10 this way, 10 this way. These boxes are out of 100. I'm just going to give you that because it's not really the important part that you're wanting to learn. I don't want you guys to spend your time counting boxes. I want you to spend your time doing math and listening to math and listening to me explain how to do this. So each one of these is out of 10. So you can count the top two. This is 20, 10, 20. And then there's only one box here, so 21. 10, 20, and 1. So 21 out of 100. So I'm going to write 21 here for our first box. And I'm just counting this. The only thing I'm doing is counting. All of you can count just fine. So I'm going to do 10s here. We have 10 boxes going across. So 10, 20, 30, and 1, so 31. And they're both out of 100. So we had 21 out of 100 up here and 31 out of 100 over here. The denominator, the 100, the denominator is the same on both numbers, so we can really just compare the two numerators and see which one is bigger. And as you can see, I'm sure most of you should be aware, you probably know, that 31 is bigger, it's a bigger number than 21. So if I were to read this from left to right, like we do in the English language, beautiful, beautiful language, good, primary language I know, 21 is less than 31. So we write less than, we write our little less than symbol here. It's like a Pac-Man guy eating the 31 because the 31's a bigger number and Pac-Man's a hungry guy and he likes to eat. The big numbers. I got some snaggletooth things. He looks like a snake now. So 21 is less than 31. So our Pac-Man is eating the 31 side. All right. And if you have done all that and understood that, you should have finished page 230 at this point, and I would like you to turn that in and give me your work so that I can give you guys good grades. You guys take it easy. Ask me if you have any questions, and I will help. I should be walking around to help you if you have any needs. Mr. Morgan out.